Saxon Algebra 1, Lesson 17. In this lesson, we learn about factors and coefficients, terms, and the distributive property. Factors and coefficients. When an expression consists of variables and constants without addition, subtraction, or division, that expression is sometimes called an indicated product. For example, the expression 4xy is an indicated product where 4 is to be multiplied by x and y. Each of the symbols is said to be a factor of the expression. Furthermore, a factor and each combination of factors is also called the coefficient of the other factors. In the expression 4xy, there are 6 different coefficients that can be named. 4 is the coefficient of xy because 4xy is 4 times xy. X is the coefficient of 4y because 4xy can be thought of as x times 4y. Y is the coefficient of 4x. 4xy is the same as y times 4x. 4x is the coefficient of y. 4xy is 4x times y. 4y is the coefficient of x. We can think of it as 4y times x. And xy is the coefficient of 4 because we can think of it as xy times 4. The commutative property of multiplication tells us that the order in which numbers are multiplied does not matter, so all of the equalities listed on the right are correct. If the coefficient is a number, as in 4 times xy, then we call it a numerical coefficient, and if the coefficient consists entirely of variables or letters, as in x times 4y, then we call it a literal coefficient. Since numerical coefficients are more important than literal coefficients, we will usually use the word coefficient by itself when we mean numerical coefficient. Thus, in the following expressions, the coefficients are the numbers in red. 4xy, the coefficient is 4. Negative 15pq, the coefficient is negative 15. 81xmz, the coefficient is 81. Now we consider terms. A term is an algebraic expression that consists of a single variable or constant, is the indicated product or quotient of variables and or constants, or is the indicated product or quotient of expressions that contain variables and or constants. For example, each of the following is a term. 4, that's a single constant, a number. X, that's a single variable. 4x, that's an indicated product. Negative 32ab is also an indicated product. Here's a rather complex looking term. It's 4xy times parentheses a plus b over p. Because of the parentheses there and the fact that it's a fraction, that can be considered a term. And here's another one without the parentheses, but because of the fraction bar, that's a single term. A term is thought of as a single entity, that represents or has a value of one particular number. We use the word term to identify the parts of larger expressions that consist of several quantities that are being added. For example, the terms of the expression x plus 4xym minus 6p over y plus 2 minus 8 are x, 4xym, negative 6p over y plus 2, because that subtraction should be thought of as addition of the opposite, and negative 8. Again, the subtraction is addition of the opposite. So if we rewrite it with the terms in color, it looks like this. It's written as a sum. The terms are separated from each other by addition. Now we consider the distributive property. Suppose a green rectangle measures 5 units by 4 units. A red rectangle measures 5 units by 3 units. And we put them together to form a larger rectangle. To find the area of that larger rectangle, we could add the areas of the red and green rectangles. The area of the green is 5 times 4, and the area of the red is 5 times 3. So we have 20 plus 15, which is 35. Or we could multiply the whole rectangle's width times its length. And the width is 5 and the length is 4 plus 3. So we would multiply 5 times 4 plus 3. In other words, 5 times 7, which also gives us 35. So you see there are two different ways we can figure the area of that rectangle. From this example, it follows that 5 times parentheses 4 plus 3 gives the same answer as 5 times 4 plus 5 times 3. In other words, the area of the whole rectangle is the sum of the areas of the two parts that make it up. This is your distributive property. We have 5 times parentheses 4 plus 3 is the same as 5 times each part in the parentheses. When a certain quantity multiplies a grouped sum, the result is the same as the sum of that quantity multiplied by each of the terms in the grouped sum. In symbols, we can write A times the grouped sum of B plus C is equal to A times B plus A times C, A times each part in the group sum. In other words, A distributes over the B and C. It gets multiplied by the B, and it gets multiplied by the C. More generally, when we have A times a sum of more than two terms, we can distribute the A over each of the terms in the sum. And likewise, if we have the factor on the right-hand side of the sum, again we can distribute over each term in the sum. Those are precise statements of the distributive property. Here are some examples. 4 times 6 minus 2 plus 5 minus 7. The 4 is going to be distributed over that sum. We have to think of the subtraction as adding the opposite. So it's 4 times 6 plus 4 times the opposite of 2 plus 4 times 5 plus 4 times the opposite of 7. It looks like this. In other words, 4 times 6 plus 4 times negative 2 plus 4 times 5 plus 4 times negative 7. That gives you 24 plus negative 8 plus 20 plus negative 28, because of course we do multiplication before we do the addition. And if you add those up, you end up with 8. Here's another example using letters. Mn times the group sum of x plus y plus 2p. The mn is going to distribute over that grouped sum. So we have mn times x plus mn times y plus mn times 2p. Which, if we simplify, putting the 2 in front of the last term, because we usually put the number first when we're speaking of a term, we have this, mnx plus mny plus 2mnp. Here's another example. The group sum x minus 3y plus xz times mp. Doesn't matter if it's on the left side or the right side, the mp is going to distribute over that group sum. So it's going to be x times mp, in other words, mp is multiplied by x, plus mp times negative 3y, which we can write as negative 3y times mp, plus xz times mp. So the mp distributes over the grouped sum in parentheses. And then if we simplify that, putting the variables in alphabetical order for each term, we have mpx minus 3mpy plus mpxz. Here's a slightly shorter example, negative 3 times 2x minus 4. The negative 3 is outside parentheses, so that is going to distribute over the 2x plus negative 4. So we have negative 3 times the 2x plus negative 3 times negative 4. And then if we simplify, that gives us negative 6x plus positive 12, because negative 3 times negative 4 is positive 12. This is the end of Lesson 17. Your assignment, problem set 17 on pages 77 and 78 of your book.